Hi friends, good evening to everyone. Welcome to my channel Belagali's class. My friends, for 12th standard for you, I have started once again with doing 1 mark and 2 mark questions. That 1 mark question will be in part A of your question paper. 2 mark question will be part B of your question paper, my friends. 1 mark questions compulsory, you have 10 examples. In 2 mark questions you have 14 they give. Out of the 14 examples you have to answer any 10 examples, my friends, that is B. Now I told I am going to do only 1 mark and 2 mark, not 3 mark, 5 mark questions. For those already I have done videos, my friends. Now you can refer those videos, especially all chapters I have done in detail, everything. Even the examples that I am doing separately for 1 mark questions, 2 mark questions, all these examples are there with those main videos, my friends. This is only to help you for the point of exam. I am doing this 1 mark, 2 mark separate sections wise examples, my friends. Main aim is to help during your exams. While doing, my friends, remember I have collected all examples from the model question papers. Even very recently means what? This reduced syllabus. Even I have collected examples, model question papers, reduced syllabus. Not only that, your textbook, your exemplar book, your miscellaneous, everything I have collected, my friends. This 1 mark, 2 mark, chapter wise I have started doing, my friends. Already I have completed 1 mark and 2 mark questions in inverse trigonometric functions. First attack is with inverse trigonometric functions, because that properties of IT of inverse trigonometric functions we use in calculus, differentiation, integration. That's why first, my friends, I have done with 1 mark, 2 mark, inverse trigonometric functions. I have done those two in 2 videos. The first video, 1 mark question. The second video, 2 mark questions, my friends. Just to refer them. After completion of that, I have started with calculus, differentiation. Differentiation, my friends, by taking 2 videos, I have completed 1 mark question. I have already completed 1 mark questions, slightly lengthy, will come under 2 mark also. Okay, that is a mixture. 1 mark questions separately I have done on differentiation, my friends. This differentiation, this is for the PUC second year or 12th standard maths class. Differentiation, and I have completed 1 mark questions in 2 videos, my friends. 2 videos. Now, this third video on differentiation I am going to do with 2 mark questions, my friends, here. It is a 2 mark questions on differentiation. For what? PUC second year. Yes, my friends, all these are 2 mark questions on differentiation. I will explain one by one. I give 1 or 2 minutes and later you have to copy it. Yes, my friends. Yes, all these 2 mark questions, remember, I am doing under differentiation. Differentiation for what? PUC second year or 12th standard maths class. Started with differentiation. Completed 1 mark questions I have completed, my friends. 1 mark I have completed. Now I am going to start with the 2 mark questions on differentiation. 2 mark questions. This is the first example. Find dy by dx if y equal to cos inverse sin x. It is there, my friends, in the model question paper, very recent 2 mark question. 2 mark question, my friends, model question paper. Now you know we have already done such examples. It is there in the main video. This sin x can be written as what? Cos 90 minus x, pi. Allied angle formula. To change from sin to cos, remember, replace your angle by pi by 2 minus x. Pi by 2 means sin changes to cos, cos changes to sin. Therefore, to change from sin to cos, Replace the angle by pi by 2 minus x, allied angle, pi by 2 minus x. Pi by 2 minus x is an angle lies between 0 to pi. Therefore, you can use property of what? Inverse trigonometric functions. Cos inverse of cos theta. Cos inverse of cos theta, where theta lies between 0 to 180, then that equal to theta itself, angle itself. This is cos inverse of cos pi by 2 minus x means pi by 2. Therefore, my friend, what is your y? Y is pi by 2 minus x. Differentiate this with respect to x. Yes, derivative of y divided by dx. Pi by 2 being a constant is a derivative with 0. Minus derivative of x is 1. X is 1. Therefore, what is the answer? Divided by dx is minus 1. Minus 1. This is just friend example. Friend example. It is cos inverse sine. Another is sine inverse cos. Same method. Convert cos to sine. If you change from cos to sine, you have to replace your angle by pi by 2 minus x. Again, sine inverse of sine. This angle is in the domain. It is what? Between minus 90 to plus 90. Use property. Therefore, sine inverse of sine theta is theta itself. This is your y, my friends. Differentiate with respect to x. Differentiate with respect to x. Divide by dx. Pi by 2 being a constant, it's a derivative with 0. Minus derivative of x is 1. So the answer is minus 1. Answer is minus 1. Yes, my friends. In these two examples, same trick. What is that? Convert the sine to cos, where outside is cos inverse. In this example, change cos to sine when the outside is sine inverse x. To use what? Sine inverse of sine theta is theta. Cos inverse of cos theta is theta. Theta means pi by 2 minus x. Oh, these two same type of examples. Then the third example, my friends, it is also by making use of what? A property done in inverse trigonometric functions. What is that we have done? Prove sine inverse root 1 minus x square equal to cos inverse x. What is another one? Cos inverse root 1 minus x square equal to sine inverse x. These are the two properties we have done in ITF, inverse trigonometric functions. Making use of that, even sometimes either 1 mark or 2 mark, they may give these examples. Again, find dy by dx if y equal to sine inverse root 1 minus x square plus sine inverse x plus sine inverse x. Yes, my friends, making use of this property, the sine inverse root 1 minus x square is nothing but cos inverse x. Again, cos inverse x plus sine inverse x, a property done in inverse trigonometric functions equal to what? Pi by 2. Then what is y? Constant. What is its derivative? The derivative of a constant is 0. I have to differentiate this with respect to x. This with respect to x. Therefore, dy by dx, pi by 2 being the constant, its derivative is 0. It's friend example. In this case, both are sine. In this case, both are cos. Find dy by dx if y equal to cos inverse x plus cos inverse root 1 minus x square. A property done, proved in case of what? ITF. So it is nothing but sine inverse x. Once again, cos inverse x plus sine inverse x. By making use of the property done in ITF, it is pi by 2. Again, derivative pi by 2 being a constant, its derivative is 0. These two same type, either 1 mark, otherwise 2 mark questions. Why 2 mark? Tell my friends. Substituting for this equal to cos inverse x. If you write this step correctly, you get 1 mark. Writing, again putting, substituting and putting this equal to pi by 2. From here to here, you have 1 mark, my friends. This is 1 mark from here to here. Writing its derivative as 0, this is another mark. It is another mark. Understood? Making use of what? Sine inverse root 1 minus x square equal to cos inverse x. Cos inverse x plus sine inverse x is pi by 2. If you write this correctly, you get 1 mark. Then writing its derivative correctly, you get another mark. It is a 1 plus 1, 2 mark question. Same here. It is both sine, both cos inverse root. Substitute pi by 2, constant, derivative 0. Even in this case, my friends, if you write this step, you get 1 mark. Writing sine x to cos, making use of the property cos inverse of cos, angle. If you write this, 1 mark. If you write its derivative correctly, this is another mark. This is 1 plus 1, 2 mark question. Same this. These 4 examples, my friends. Next, one more property is there, my friends. One more property. That property, I will first explain this itself. In general, in differentiating a function of y with respect to x, in differentiating function of y with respect to x, what your rule says, if it is other than x, first to differentiate a function of y with respect to y, then differentiate y with respect to x. Derivative of y with respect to x is always dy by dx. Remember, it is what? A function other than x. Here we have taken fy. To differentiate a function of y with respect to x, first differentiate function of y with respect to y, then y with respect to x. Remember, my friends. The same thing I have written some formula here. Means examples, verifications. Derivative of y with respect to x is dy by dx. Y dy by dx. What is this? Other than y, my friends. It is a derivative of y square with respect to x. Other than y. If it is other than y, first differentiate other than y with respect to y first, my friends. With respect to y, then y with respect to x. Derivative of y square with respect to y is 2y into dy by dx. Yes, this is derivative. Then I have taken sin y. In differentiating sin y with respect to x, first the derivative of sin y with respect to y, then y with respect to x. No. Sin x with respect to x is cos x. Sin y with respect to y is cos y. Y. Then, if it is other than x, into dy by dx is must. Why? After writing with respect to y, then y with respect to x. This must include here x. Then finally, you have to write derivative of y with respect to x. This time. Derivative of sin y is cos y into dy by dx. Log y. What is derivative of log y? First log y with respect to y, then y with respect to x. So what is derivative of log x with respect to x is 1 by x. Log y with respect to y, x. Y means 1 by y into dy by dx. Yes, in general, in differentiating any function of y with respect to x, first differentiate that function of y with respect to y, then derivative of y with respect to x is dy by dx. My friends, remember, this is a very important step. Then I do some examples based on this. Even this we use while differentiating implicit functions. We use this rule, my friends. What is that? While differentiating any function other than x with respect to x, first differentiate that function respectively with the same variable. If it is y, if it is u, if it is t, first with respect to t, then t with respect to x. If it is y, first with respect to y, then y with respect to x. Remember, my friends. This is one example from your model question paper under 2 mark questions. It is a new model question paper given this year with a reduced syllabus, my friends. Reduced syllabus. This example is there in the model question paper. If y equal to sin log x, then prove sin log x, then prove dy by dx equal to root 1 minus y square upon x. Root 1 minus y square upon x. Yes, my friend, given y equal to this. Bring sin this side. Sin taking this side becomes sin inverse y equal to log x. Differentiate with respect to x. Differentiate with respect to x. Derivative of LHS equal to derivative of RHS. You are differentiating a function of y with respect to x. First function of y with respect to y, then y with respect to x. You know derivative of log x with respect to x is 1 by x. What is sin inverse y? 1 by root 1 minus y square into dy by dx equal to 1 by x. Solve for dy by dx equal to denominator you take to the numerator. Square root 1 minus y square upon this x. This is dy by dx. This, my friends. Now one more parallel example is there. I do that just to copy these examples, my friends. Copy it. Copy it. These are simple examples. This comes under 2-mark questions. 2-mark questions. That's 5. This is example number 6. If y equal to sine of 2 sine inverse x, if y equal to sine of 2 sine inverse x, then prove dy by dx equal to 2 into square root 1 minus y square upon 1 minus x square. 1 minus x square. Right, friend, given y equal to sine of 2 sine inverse x. 2 sine inverse x. Same, take this side, it becomes sine inverse y equal to 2 times the sine inverse x. Differentiate with respect to x. With respect to x, this derivative of sine inverse 1 by root 1 minus y square into dy by dx. My friends, in detail I have explained here. First with respect to y, then y with respect to x. Same here. First with respect to y. What is the derivative of sine inverse y with respect to y? Is 1 by root 1 minus y square into derivative of y with respect to x is this. Otherwise, if you wanted, you can write one step more. Differentiate with respect to x. Yes. It is d by dx of sine inverse y equal to 2 into, this is d by dx of sine inverse x. Sine inverse x. What is this? 1 by, first with respect to y, root 1 minus y square into dy by dx equal to 2 into derivative of sine inverse is 1 by root 1 minus x square. 1 minus x square. Take that side. Therefore, dy by dx equal to, already this 2 is there, this root 1 minus y square upon root 1 minus x square, which is 2 into square root 1 minus y square upon 1 minus x square. Hope understood. Hope understood. Copy it, my friends. I will explain once again. I will explain once again. Yes, friends, this same parallel. If y equal to sine of 2 sine inverse x, then prove dy by dx equal to 2 into root 1 minus y square upon 1 minus x square. Given, take the sine that side, sine inverse y equal to 2 into sine inverse x. Differentiate with respect to x. Derivative of LHS with respect to x, 2 into k, constant coefficient. Derivative of sine inverse x with respect to x. First with respect to y, 1 upon root 1 minus y square into derivative of y with respect to x, dy by dx, 2 into. This is with respect to x only, 1 upon root 1 minus x square. Solve for dy by dx, 2 into this denominator to the numerator, already denominator is there. Simplify, common square root, 1 minus y square, 1 minus y square upon 1 minus x square, which is this, my friends. This I have done with a pair, jodi, 2 examples, same type, 2 examples. Then, my friends, according to your model question papers. Examples on second derivative. This is what? dy by dx. What is second derivative? d2i by dx2. d2i by dx2. If you differentiate the same with respect to again x, that is symbol d2i by dx2. d2i by dx2. My friends, this, see, note, you can say, note. If y equal to fx is a function of x, differentiate with respect to x. What is this, my friend? Derivative of y with respect to x is dy by dx equal to this. It is a derivative means d by dx of fx means it is f dash x. It is f dash x. Differentiate again with respect to x. It is d by dx of first derivative dy by dx equal to, what is this? D by dx of, it is f dash x. See, my friend, symbol, if you differentiate first derivative, you get second derivative of y with respect to x. What is it? Second derivative of y with respect to x. Everything we have explained in successive differentiation. Just reminding, I am explaining. Derivative of first derivative is second derivative. What is the symbol? d2i by dx2 or d square y by dx square. What is this? First derivative, f dash. Again, second derivative. Second derivative is what, my friend? 2 dash. Same. This is with respect to f. F double dash is the second derivative. With respect to y, d2i by dx2 is second derivative of y with respect to x. Second derivative of f with respect to x. Yes, my friends. Remember. Now I am going to do some examples on this successive, means this second derivatives. As in the new, you have one example under 2 mark questions. Now I do mark the examples given in your textbook as well as model question paper. Some examples I will do on second derivatives, my friends. I hope this is clear. Explain. Now I am going to do the second derivative examples, my friends. Yes, my friends. Now these are some examples on. These are some examples on 2 mark questions on second derivatives, my friends. 2 mark questions on second derivatives. They are there in the model question papers. 2 mark question. These are the examples from the exercise 5.7. Exercise 5.7 and worked examples, my friends. These are worked examples. In that chapter. This is the first example. Find d2y by dx2 if y equal to x cube plus tan x. Find the second derivative of y with respect to x if y equal to x cube plus tan x. Yes, friends. It is a solved example in the textbook. It is given in the model question paper 1, which is what? That reduced syllabus. Model question paper given this year, 2021. Yes, in the first model question papers. Yes, this is the solution. Given y equal to this, differentiate with respect to x. Derivative of y with respect to x is dy by dx. Derivative of RHS, derivative of first plus is plus derivative of second. X cube, 3x square y n into x to the power n minus 1. 3 n minus 1 is 2 plus derivative of tan x is sec square x. Differentiate again with respect to x. Derivative of first derivative equal to d by dx of this RHS. Derivative of first derivative is what? Second derivative of y with respect to x. Second derivative of y with respect to x. 3 into 2, 6x, 1 power less, 2 sec x into derivative of sec x with respect to x. 2 sec x into derivative of sec x with respect to x is, it is sec into tan. It is sec into tan. Simplify it. 6x to Sec into sec is sec square x into tan x. This is d2i by dx. My friends, if I write first derivative, they give 1 mark. If you write this correctly, this is 1 mark. If you write this second derivative, you get another 1 mark question. It is a 2 mark question. 2 mark question. This is second example, my friends. If y equal to 5 cos x minus 3 sin x, then prove d2i by dx2 plus y equal to 0. It is given in the model question paper 2, my friends. This is model question paper 2, under 2 mark question. Same. This is given. Given y equal to 5 cos x minus 3 sin x. Differentiate with respect to x. Derivative of y with respect to x is dy by dx. 5 into derivative of cos x minus 3 into derivative of sin x. My friends, instead of writing directly from here to here, I have written this supportive step, my friends. It is that supports you, supportive step. 5 into derivative of cos is minus sin x. Minus 3 into derivative of sin x is cos x. Differentiate again with respect to x. Derivative of first derivative. Derivative of first derivative. Minus 5 into, this is minus 5 into derivative of sin x. Minus 3 into derivative of cos x. Yes. Derivative of first derivative. Second derivative. d2i by dx2. Minus 5 into derivative of sin x is cos x. Minus 3 into derivative of cos is minus sin x. Minus, minus. Minus is common, taken out. Minus, minus. Minus is out. You are left with 5 cos x. One minus is taken outside. Another minus is left inside. This is 3 sin x. Minus, see, what is this bracket? This bracket, 5 cos x minus 3 sin x. 5 cos x minus 3 sin x is nothing but given y. Given y. Substitute this bracket equal to y with this minus sign. Minus y taking this side. It is d2i by dx2 plus y equal to 0. This is what we wanted, my friend. This is second example. Given, differentiate dy by dx, 5 into derivative of cos minus 3 into derivative of sine. Write the derivative of cos minus sine, derivative of sine cos. Differentiate again with respect to x, derivative of first derivative. Minus 5 into derivative of sine x, minus 3 into derivative of cos x. This is second derivative, symbol d2i by dx2. Everything is explained in the earlier differentiation videos, successive differentiation. We have done a lot of examples there. One day I have taken all these basics explained, my friends. This is minus 5 into derivative of sin x is cos x. Minus 3 into derivative of cos is minus sin x. Minus, minus, minus is common. Left inside 5 cos x. One minus is taken outside, you are left with another minus here. This bracket is nothing but 5 cos minus 3 sin is y. Substitute minus y taking to LHS plus y equal to 0, which is what we wanted. And this is, my friends, second example. Second example is there in the model question paper. These are examples from your exercise 5.7 and question papers also, my friends. If y equal to 500 into e to the power 7x plus 600 into e to the power minus 7x, then prove d2i by dx2 equal to 49y, 49y. Given 500 into e to the power 7x plus 600 into e to the power minus 7x. Differentiate with respect to x. dy by dx. 500 into derivative of e to the power 7x plus 600 into derivative of e to the power minus 7x with respect to x. Right. Derivative of e to the power f into f dash. E to the power 7x other than x. Write the derivative of power. What is the derivative of 7x? 7 plus 600 into e to the power f, e to the power f into derivative of power minus 7x. What is the derivative of minus 7x? Minus 7. Why tell? All the while I used to tell while doing differentiation. Derivative of x is 1. Derivative of kx, kx is k. 7x is 7. Minus 7x is minus 7. K. Differentiate again with respect to x. I have written directly. Derivative of first derivative. Derivative of first derivative is second derivative. Symbol d2i by dx2. 500. This 7. This 7 into derivative of e to the power 7x. E to the power 7x other than x into a derivative of power is 7 plus 600 derivative of e to the power minus 7x minus 7 into e to the power minus 7x derivative of power minus 7. 7 into 7 49 minus 7 into minus 7 49. 49 is common, left with inside 500 into e to the power 7x plus 600 into e to the power minus 7x. This bracket is nothing but y. This bracket 500 plus 600, this, which is y. Therefore, d2i by dx2 LHS equal to 49. This bracket is nothing but y. My friends, if you wanted here, you can write derivative of 7 into derivative of e to the power 7x. 600 into minus 7 into derivative of e to the power minus 7x. If you wanted that supportive step, you increase this by another step. Then you write its derivative. Derivative of this 7x into 7. Derivative of e to the power minus 7x. It is same with minus 7. 49 common 1. Yes, my friends. Copy. This you do at home, DIY. Same parallel example. DIY. If y equal to, this is a cos x plus b sin x. Instead of some numbers 5, 6 here, 5 is there, minus 3 is there. Instead of 5 and minus 3, the friend is given in general a and b. Then prove d2i by dx2 plus y equal to 0. Same thing. Yes, you do it yourselves, my friends. Do it yourselves. Yes, my friends. In the next example, it is also from the exercise 5.7 from that. If y equal to cos inverse x, then find d2i by dx2 in terms of y. If y equal to cos inverse x, then find d2i by dx2 in terms of y. My friends, given y equal to cos inverse x, bring cos inverse x this side, cos y equal to x. Differentiate with respect to x. Derivative of LHS equal to derivative of RHS. It is a supportive step, my friends. Supportive step. If wanted, you can write, otherwise directly you can jump and write this step. Jump and write. I have written only because to support. Mistakes are less. Derivative of LHS equal to derivative of RHS. Derivative of cos with respect to x. Cos y, first with respect to sine, it is minus sine y. Derivative of cos is minus sine y into dy by dx equal to 1. Yes, so dy by dx is 1 upon minus sine y. Minus sine y. This is minus cosec y. Minus cosec y. Differentiate again with respect to x. Derivative of LHS, derivative of first derivative is second derivative, symbol d2i by dx2. d2i by dx2. Then d by dx of RHS. Yes, minus. Already you have minus here, this outside. I use this bracket, my friends. Minus I have written here. This is what? Cos y. Derivative of cos is, otherwise I write this minus here, my friends. Minus here. Minus. d by dx of cos y minus derivative of cosec minus cosec y into cot y into derivative of y with respect to x is dy by dx. This is minus with minus is plus. Minus with minus is plus. Cosec y into cot y. What is dy by dx, my friend? That dy by dx is minus cosec y. This is minus cosec y. Dy by dx. Dy by dx is minus cosec y. So what is the answer then? Minus cosec into cosec. This is minus. Minus cosec square y into cot y. This is d2i by dx too in terms of y, my friends. Free from x, purely RHS is in terms of y. So the second derivative is in terms of y. That is minus cosec square y into minus cosec square y into cot y. I will explain once again, my friends. If y equal to cos inverse x, then find second derivative d2i by dx. Give d2i by dx in terms of y, purely in terms of y, that should be free from x. Given y equal to cos inverse x, cos inverse take this side, cos y equal to x. Differentiate with respect to x. Derivative of cos y equal to derivative of x. Cos minus sin y into dy by dx. Why? First with respect to y, then y with respect to x. Derivative of x with respect to x is 1. Shift down. 1 upon minus sin y, that is minus cosec y. Differentiate again. Derivative of first derivative, second derivative. This minus outside d by dx of cosec y. Minus into first with respect to y, minus cosec y into cot y. Then derivative of y with respect to x is dy by dx. Minus with minus is plus. Cosec y into cot y. What is the dy by dx? Dy by dx, from this you can say, my friends, this is 1. 1. Because of 1. Because by 1. Dy by dx is minus cosec y. Minus with plus minus. Cosec into cosec. Cosec square y into cot y. So it is d2i by dx too, purely in terms of y, my friends, in terms of y. This is one example. It's also a good example. Under 2 mark question, slightly 1 or 2 steps here and there, more or less. It is next example given in the same exercise 5.7. If y equal to, if e to the power y into x plus 1 equal to 1, e to the power y into x plus 1 equal to 1, then prove d2i by dx to equal to dy by dx the whole square. d2i by dx to equal to dy by dx the whole square. My friends, this is given e to the power y into x plus 1 equal to 1. Name this as 1. Differentiate with respect to x. Product e to the power y is one function, x plus 1 is second function. It is a product of two functions, u, v. Use product formula. First function as it is into derivative of second function plus second function as it is into derivative of first function equal to derivative of RHS 1 with respect to x. Write their derivatives. It is e to the power y into derivative of x is 1 plus 1 being a constant 0. 1 plus 0 is 1. X plus 1 into it is once again other than x, first with respect to y, then y with respect to x. First e to the power y with respect to y, then y with respect to x. Derivative of 1 is 0. This is e to the power y into 1 plus e to the power y into x plus 1 into dy by dx. I have collected this in the bracket. Then dy by dx equal to 0. But what is this by 1, my friends? E to the power y into x plus 1 is 1. The value of this is 1 because by 1, this 1. Substitute. This becomes 1. 1 into dy by dx equal to 0. So dy by dx is shifting that side minus e to the power y. Differentiate with respect to x. Differentiate with respect to x. Here. This is derivative of first derivative equal to minus derivative of e to the power y minus derivative of e to the power y. Derivative of first derivative, second derivative, minus e to the power y into then y with respect to x dy by dx. But what is the value of minus e to the power y? Minus e to the power y is dy by dx. Dy by dx. So it is dy by dx into dy by dx, which is dy by dx the whole square. So the second derivative of y with respect to x is dy by dx into dy by dx is dy by dx the whole square. This is what you wanted, my friends. It is also another good example. Good example. Copy it. I will explain once again, my friends, this. Once again I will explain. Yes. This is given. You want to prove this. dy by dx equal to dy by dx the whole square. Given, differentiate with respect to x, u, v, product formula, first function into derivative of second plus second into derivative of first equal to derivative of 1 in 0. E to the power y into derivative of x is 1 plus x plus 1 into, what is this, implicit other than x, first with respect to y, then y with respect to x. If it is other than x, remember my friends, always dy by dx into 1 in 0. Yes. This is e to the power y into 1 plus, I written this as what? E to the power y into x plus 1 into dy by dx equal to 0. But what is this by 1? This is by 1, nothing but 1. That is 1 into dy by dx equal to 0. Shift plus becomes minus e to the power y. Differentiate with respect to x this. Derivative of this, second derivative. Again minus into e to the power y. With respect to x means first with respect to y, then y with respect to x. So minus e to the power y into dy by dx. This I have kept it in the bracket. Again by 2, my friends, by 2 minus e to the power y is dy by dx. Minus e to the power y is dy by dx. Substitute. This is nothing but dy by dx. Same square. So dy by dx to equal to dy by dx the whole square. It's also one slightly change. Good example, my friends. It is a good example. No doubt. No doubt. Copy it. Copy it. Both are good examples. Little change. Here also purely in terms of what? That is dy by dx the whole square. All these 5, 6 examples, my friends. These are the examples on second derivatives, my friends. Second derivatives. These are from your book. Even solved examples are also included, my friends. Included. Yes, prepare them. Prepare them. Then I do another very simple examples on second derivative. Very simple examples on second derivative. Yes, my friends. Very simple examples. Find the second derivative of y with respect to x if y is 2 to the power x. Sometimes they go, it's very simple. Given y equal to 2 to the power x, differentiate with respect to x. Derivative of y is dy by dx. Derivative of RHS, suppurative step. What is the derivative of a to the power x? A to the power x into log a. Other than e means log of the base. 2 to the power x into log 2. Differentiate again with respect to x. Derivative of first derivative is second derivative, log 2 into d by dx of 2 to the power x. 2 to the power x into log 2. So if you simplify, it is 2 to the power x into log 2 the whole square. So d2i by dx2 is 2 to the power x into log 2 the whole square. This is, do it yourself. What is the change? Instead of 2, it is a, you get a to the power x into log a the whole square. Do at home, do yourselves. This is first 2 to the power x into log 2, again 2 to the power x into log 2 as it is, 2 to the power x into log 2, log 2 whole square into 2 to the power x. This is the second derivative. Now for the first derivative 1 mark, for the second derivative second mark. This is a to the power x. Even they may give minus here. If it is minus, into minus 1 comes here. Minus 1 comes repeated means it comes plus itself. Y equal to tan inverse x, another example. Differentiate with respect to x. dy by dx equal to d by dx of tan inverse x. Derivative of tan inverse is 1 upon 1 plus x square. Differentiate again with respect to x. Derivative of first derivative is second derivative. D by dx of 1 upon 1 plus x square. 1 by phi, my friends, if wanted, I just remind here. It is derivative of 1 by phi with respect to x is minus d phi by dx upon phi square minus the denominator minus the derivative of denominator upon square of the denominator. 1 upon 1 plus x square. This is phi, my friend. Phi. Derivative of phi upon phi square. What is the derivative of 1 plus x square? Minus of this minus comes. Minus 0 plus 2x. Means it is minus 2x upon 1 plus x square the whole square. So this is the second derivative. This is the second derivative. What is it? Y equal to tan inverse x. Differentiate. Derivative of tan inverse x. Again differentiate with respect to x. Second derivative. It is 1 by phi. 1 by phi. Minus the derivative of denominator upon phi square. This 2x with minus sign is minus 2x upon 1 plus x square the whole square. This is second derivative. Sometimes the friend will ask in a different way. If y equal to tan inverse x, then prove this, my friend. Then prove this. Prove 1 plus x square. 1 plus x square whole square into d2y by dx2 plus 2x equal to 0. Plus 2x equal to 0. Yes. This, my friends. Same. You take this side. Up to this you have to write everything. Bring this to this side. That 1 plus x square whole square this side into d2y by dx2 equal to minus 2x. Minus taking this side is plus 2x equal to 0. So you have to write this one step or two steps more to get this, my friend. If y equal to tan inverse x, then prove this, my friends. This. Oh, understood. Understood. The same similar log x to the base e. Differentiate with respect to x. dy by dx equal to derivative of log x to the base e. Log x is 1 by x. Again differentiate. It is what? 1 by x means 1 upon x to the power n on this, my friends, because d by dx of 1 upon x to the power n is minus n upon x to the power n plus 1 applied. The power of x is 1 minus 1 upon x to the power n plus 1 this n plus 1 1 plus 1 is 2. 1 plus 1 is 2. If it is n, 1 more. If it is 1, 1 more means 2. Same. Otherwise, again, you would simplify it. X square into d2y by dx2 is minus 1. Taking this side is plus 1. Plus 1. Yes, my friends. Same. Same. Copy it. I will do another one or two examples of this, my friends. Copy it. Yes, my friends. So the next example is find dy by dx if find d2y by dx2 yes, my friends, another one. Find d2y by dx2 if y equal to log x, y equal to log x. In both the cases, the base is e. Same example I have done in case of what? Only first derivative. There, this base is 7, my friends. This base is 7. Yes, see. If y equal to log x, when the base is not written, the base understood, it is e itself. Differentiate with respect to x, derivative of y. First derivative of RHS. It is log f. Log f means, you know this, my friend. Derivative of log fx. Derivative of log fx with respect to x is, it is 1 by fx into derivative of fx. What is this, my friends? This is derivative of log fx. What is the formula general? 1 by f into derivative of f. Log f. 1 by f into derivative of f, log x. Once again, derivative of log x is 1 by x. Therefore, dy by dx is x log x. Dy by dx is x log x. Differentiate again with respect to x. This is same as 1 by phi. 1 by phi. 1 by phi is what? 1 by phi. Minus dv by dx upon phi square. Minus the derivative of denominator upon square of the denominator. Product formula x into log x. U phi. Use product formula. First into derivative of log x, 1 by x, plus log x into derivative of x is 1 upon x log x the whole square. X cancels, you are left with 1 plus log x upon x log x the whole square, which is the second derivative of y with respect to x. It is the formula. It is the answer. We will explain once again. Y equal to log x. Differentiate with respect to x. Derivative of y with respect to x is dy by dx. Derivative of RHS. Log f. 1 by f into derivative of f. Derivative of log x is 1 by x. Simplifying x log x. It is first derivative. Differentiate again. Derivative of first derivative is second derivative. This is 1 by phi minus the derivative of denominator upon square of the denominator. Minus the derivative of denominator with respect to x upon square of the denominator. Minus product formula x into derivative of log x is 1 by x plus log x into derivative of x is 1 upon square. X cancels, gives 1 minus 1 plus log x upon x log x the whole square. This is second derivative of y with respect to x. This general formula is used, log f 1 by f into f. This is another example. This example is from the exemplar. It is a good example under 2-mark question. Little change. If fx equal to mod cos x, find f dash pi by 4. F dash pi by 4. Since pi by 4 belongs to the interval 0 to pi by 2. Since pi by 4 belongs to 0 to pi by 2 and cos x is positive in the first quadrant, therefore fx equal to that mod cos x in this interval becomes plus cos x. As pi by 4 belongs to the interval 0 to pi by 2. In 0 to pi by 2, cos x is positive. In 0 to pi by 2, cos x is positive. Therefore, fx equal to mod cos x as it is positive becomes plus cos x. Differentiate f dash x cos minus sin x. To get f dash pi by 4, put x equal to pi by 4. F dash pi by 4 equal to minus sin pi by 4. Sin 45 is 1 by root. What is the answer? Minus 1 by root, which is the answer for this question. My friends, these are some examples I have selected for what? Second derivatives. If you wanted, I may do another 2 or 3 examples by making use of what? Product formula. one or two product formula, one or two quotient formula. Actually, they are little lengthy examples, but as a samples I do. As a samples. Yes, my friends. Today, this much is enough, my friends. This much is enough. In the next class, I will continue with this. Successive means second derivatives. Second derivatives means 2-mark questions. I will continue with 2-mark questions. 2-mark questions. Yes, my friends. In the next video, a few more examples. Especially, I want to do some examples on implicit functions. 2-mark questions, one example. Then logarithmic differentiation. They are also simple examples. They may ask under 2 mark. All these examples already we have done. Implicit, complete 1 or 2 videos I have done. This is logarithmic differentiation. One function to the power another function. There also I have done. But from that I have selected very few examples which are fit under 2-mark questions. Fit under 2-mark questions. Selected, then I want to do in the next video. Some examples 4, 5 on implicit, 2, 3 examples on logarithmic differentiation. One function to the power another function. That, my friends, I do in the next class or next video. Till then, my friends, enough. Namaste, Namaskara, Namashina. Thank you very much, my friends. Thank you. Thank you.